In this video, we are going to learn one of the very important technique is called the transformations. So the goal is like knowing the graph of uh, one function, like for example, let's say you know the graph of y equal fx. Now the question is how to obtain the graph of y equal gx. So gx is a function of fx. So it will be very clear once we do more examples. The idea is you know the graph of one function and you have a transformation. That new transformation is called gx, and how to get the graph of gx. So that's the goal. So before you study this one, make sure that you know how to graph those standard functions, or what we normally call the library of functions. So there are about 14 basic graphs. So let's go go over that video and make sure that you understand all those graphs and how to graph them quickly, because then you can save some time, because otherwise you might see it's very difficult because you don't know what are those basic graphs. You can see the link in the description for the basic graphs. So let's say we know about that, and then you can continue from this one. So there are three cases to consider. So what are those three cases? So we can talk about vertical and horizontal shift, and then we talk about how to do the compressions and stretches. So like how to get the graph smaller and stretch make it bigger. So it's like a scaling factor. So this is like what we normally call scaling. So scale the graph. Uh, Good. And then we also have what we call the reflections. So we can talk about two type of reflections. We can talk about reflection about the x-axis, and we also talk about the reflection about the y-axis. So there are a few tips that you want to remember. So let's say you have a function y equal fx. So we call this is the inside of the function, um, inside the parenthesis, and this is the outside of the function. So what happens? So there are two very interesting things, and unfortunately we cannot find that in textbooks, but this is very useful when you try to plot certain graphs. So what is the first one is like if you make a outside change, for example you multiply by 2 this function, or half it, or negate, put the negative sign, those are outside changes. So if you make an outside change, so we can write like that. If you make outside change, what's going to happen? You only see a vertical changes, like it's only change the y coordinates. So it's very clear, is that right? So those are only vertical changes. So you can see this is very useful when you try to do certain times, like you get complicated graphs and you really don't know what's going on. So in this case, this is useful. And then the other one is if you make an inside change, like let's say you're going to multiply x by 2, like 2x. So that's the inside change, or x minus 1, x plus 1, things like that. So those are what we call inside changes. So if you do an inside change, what happens? Those are horizontal changes. You're going to see horizontal change. You don't see any uh, vertical changes. So those are horizontal changes. So those two are very useful when you try to so remember, outside is a vertical change only, inside is a horizontal change only. And then also when we graph, we normally, this like a works most of the time, we're going to start with the inside of the function and then try to go to the outside of the function. So that's the kind of thing we do. We start with all the way inside, and then we're gonna slowly move on to the outside of the function. Okay, so those are three tips that we're gonna use later, and it will be very useful for when you try to graph. So let's start with the easiest one. So we do easiest one. For example, the vertical shift, the shift are easiest. So we do shift, and then we do the reflections, and at the end we do the stretches and compressions. Okay, so let's do the first one. What's the first one? The vertical shift. So we have so vertical shift is the easiest. Vertical shift. Um, and then we do this at the end. That's the last thing we do. Okay, because this is the easiest, and you can see the changes are it's a vertical change. Because that's normally the last thing we're gonna have when we start with the function. This where we end up. So vertical shift. So let's assume that you have a function y equal fx, and then we assume that k, there's a number which is positive. So there are two things. So the question is, the first one is the graph of the graph of the graph of y equal fx plus k. So you add the k value. Is the graph of y equal fx is the graph of y equal fx shifted vertically upward, shifted vertically uh, upward, shifted vertically upward k units, units. So shifted vertically upward k units. Okay, that's what happened when you have fx plus k. So you can see that this is like a very simple situation. What we're trying to do, you simply change the y coordinate, just the y coordinate. So changing y coordinate means you move the graph up or down, but since you are adding a positive number, it moves upward. How much? K units. Okay, so it's very clear. And then the next one, the graph of y equal fx minus k is the graph of y equal fx. Now again shifted vertically, downward. I just said down. Okay, shifted vertically down k units. So this is very clear from the previous one. So what we have is you're gonna say fx minus k. That means you subtract, you bring the y coordinate down. How much? K units. So that means you move the graph shifted vertically down k units. So let's see. This is in a graph. So how it looks like? It will be easy to remember. So let's say you have a uh, graph like that. So what's going to happen? So let's say this is the uh, uh, yeah. Let's do the. So I'm going to change this one a little. So let's say this is the graph. So what's going to happen? Let's say you're going to add k. So what happened when you add k? So you're going to move the graph k units up. So that's it's going to go. It's the same graph, but you move the whole graph k units up. Okay. So that is the. So this is the. If you say fx graph. So this is fx plus k. So what you do, you shift the whole graph k units up. So everywhere you move k units up. Good. And if you look at the other one, so what's going to happen here? So you can see, so this is your original graph. Now we're going to bring is down by k units. So all the points you down by k units. So what happened? So you're going to see that. So this is your new graph. It's going to go like that. So you can see is k units down. So this is the y equal fx graph. So this is the y equal fx minus k graph. So you simply move a graph down. So what we normally do, we kind of evaluate maybe like 3 points, and then we can connect the dots if you need a very neat graph. So you can like, for example, find three like boundary points. So about 3 boundary points, or it actually depends on the graph. So normally what we do, we can find 3 boundary points, and then we can move the graph depending on that. So if it's a positive, you move up. If it's negative, move down. But you can see that since it is a outside change, because you add that, so it's outside change, depending on the due to our tips that we talk about, you can see it's only a vertical change. So there are no changes in the horizontal direction because it's outside. So it's only a vertical change. So so let's look at a example. So how about this one? So let's say you have so use the graph of y equal x squared. Okay, use the graph of y equal x squared. Use the graph of y equal x squared to sketch the graph of to sketch the graph of let's do two. So first one is, let's say gx equal x squared plus 3, just some number, just pick some numbers. And let's say b hx which is x squared minus 2, some number, doesn't matter what number is. Okay, so now you can see this is like you add a add for the part A, you just add plus 3. That means you're going to move the graph shifted upward 3 units. Okay, so we can first detail. So the first one, so you can see part A, the graph of um, gx equal x squared plus 3 is the graph of y equal x squared shifted upward by 3 units. Okay, shifted up 3 units. So since we know the graph of that, so now let's we know this is one of the basic graphs. So we know the graph of y equal x squared. This is the parabola. So we have this one. Uh, so uh, so this is the graph of y equal x squared. Now what we're gonna do, we're gonna lift this graph up by 3 units everywhere. So each point gonna move 3 units up. So that's the new point. And this one also go 3 units up. So that's the new point. Same thing. So move each point 3 units up, and then you're gonna connect those dots, and then you're gonna get the new graph. Okay, so it's very clear. So that means so finally we get the graph like this. So the new graph is gonna, so earlier you can see the original graph pass as 0, but that point moved to 3. That means the new graph gonna pass at 3. Good. So yeah, so that's a graph, and it's gonna see, we're gonna put 2 arrows to mean that it's gonna continue. So that is the new graph. So what is the domain? So let's try the domain and the range also. So domain of this function, so it's a parabola. So the domain is the domain of g, which is all real numbers. So that means negative infinity to infinity. What's the range? So you can see the range is in the earlier, the range that start at 0 and go all the way up. But now it's only start with 3. So that means 3 to infinity. So that's the range of the new graph. Okay, so let's do the next one. So next one is also, we start with the same graph. So we have, so part B. So you can see the graph of hx equal x squared minus 2 is the graph of y equal x squared shifted down by 2 units. So shifted down by 2 units. So again, so we can start with the original graph. So we have the parabola, uh, and then what's gonna happen now? It's gonna go down. It's gonna go down by, so each point's gonna go down by 2 units. Good. Um, and then so we're gonna get the new graph. So I'm gonna move the axis because you can see it's gonna go there. So I'm gonna move the axis like somewhere there just to get a better graph. Because we're gonna have like a good viewing window. That's what we normally call. Okay, so so what happened now? All the 3 points gonna move down. So so that means your new graph gonna look pass through 2. So it's gonna go like this now. Gonna go like that and pass it through. Okay, so it is in this case -2. Okay, this pass through -2. Good. So that is the graph of actually this is, can we just say h, so let's do the same one. So this is a graph of hx equal x squared minus 2, because you move the graph down 2 units. So this is the graph of y equal x squared. So this is what we call transformation techniques. You just move the graph all the way down. Okay, so it changed all the intercept, uh, both intercepts, x-intercepts and the y-intercept. Very good. I'm going to give you a note. Normally, this is the step we do at the end. So when you have like a transformation with multiple steps, we don't do this step. This is the last step we do. Okay. So because remember, it's inside out. Because since out, this is the last thing we do at the end, because that's outside of the function. So normally, so this is like something can help you later. Okay. Normally, do at the end. Okay, so it's very important. It's going to help you a lot. Okay, so so that's about the vertical shift. That's very easy. Move up and move down depending on you add or subtract. So let's do the next one. Number 2, the horizontal shift. So the horizontal shift. Horizontal shift. Um, so again, let's assume. So what are the situations? So we're gonna consider these cases now. So let's say you have a positive h value. So let's say we're gonna do these two cases. So one is f x minus h. You can see it's inside. That means it's only horizontal changes. And the other one is y equal f x plus h. So this is very interesting. What happened in these two situations? Actually, you can also look at this as x minus h to bring it to the same format. So that means it go backward. So you can see it's exactly the opposite direction because there's a minus h. So one go to left, the other one go to right. So it's like that. It's just gonna go reverse. So what's really going on here? So you can see that what we try to do is we try to read the values from the original graph. So we try to read the coordinate or read the y values from the original graph. But if you make a shift like that, if you say x minus h, so when you say x minus h, what happens every time you subtract h amount from the x coordinate? So that means to read the actual value from the graph, what do you want to do? You have to move the graph to the right in the first case because you're subtracting here. Just to cancel out that, what do you want to do? You want to move the graph to the right so that they cancel each other. So that's the whole point. So that means in this case, what we can do, since you're subtracting, to cancel that, we're going to move the graph h amount to the right so that they cancel each other. In the other one, what we do, since you're adding, to cancel that, what we can do, you move the graph to the left h unit so that they cancel each other. So the goal is to cancel what's going on inside. So and then you read the exact value from the same graph. That's why you're gonna move the graph so that they cancel each other. When you subtract, you move to the right so that you add and subtract. In the other one, since you add, you subtract. To subtract, you're gonna move to the left. Okay, so that means inverting. So let's write what we do here. Uh, so the first one is the graph of the graph of y equal f x minus h is the graph of y equal fx shifted to the right, shifted to the right, shifted to the right uh, uh, by h units. So again, so what was our argument? And you can see, since you subtract, what you want to do, you want to move, you want to increase by h unit. Okay, so we can say, since you subtract, so we need to increase the x coordinate, need to increase by h units. Okay, so that's why we move to the right to increase the x coordinate by h units so that they cancel each other. Okay, so that's the idea. So shifted to the right by h. And similarly, the other one, so what we have, the graph of y equal f x plus h is the graph of y equal fx shifted to the left, shifted to the left, shifted to the left by h units. Again, since you are adding inside, because you add plus h to the coordinate just to cancel each other, what we're gonna move, we're gonna subtract that h amount from the coordinate, from the x coordinate. That's why we move the whole graph to the left to subtract it. So now shifted to the left by h unit. Okay, so yeah, so that's what you'll remember. So if it's a minus h, you move to the right. If it's plus h, you move to the left. So let's look at a graph and see how it looks like in these two cases. So let's say we have these two graphs. So that is one graph. So what we want to do, so this is the minus h case. That means you're going to move the graph to the h unit. You're going to move the graph h unit. So it's a h unit. So that means this is the graph of y equal f x minus h. So you move, that means you increase the x coordinate. Since you move the increase x coordinate, since you subtract inside, they cancel each other. Okay, so you read the values from the original graph. You can see, because the y value stay the same. Okay, that's the whole point. Y value stay the same. So you pretty much, so to get this value, you actually read this value, because you do not change the y values, they stay the same, because outside it's an inside change. So that means it doesn't happen in the y direction, it's only happen in the x direction. Good. So and similarly, so let's look at the other graph. So what happened in the other case? So let's say this is your graph. Now what we can do, we're gonna move the graph to the left h unit. So that means so this is the graph of y equal f x plus h. Okay, since you add inside, you move the graph to subtract that change. So that means you pretty much you read the same y values in the both graphs. That's the whole point. Good. So those are the horizontal shift. So let's try to look at a situation and try to see how this works. So let's do this. So we have the next example. Use the transformations. Use the transformation method. Use the transformation method. Use the transformation method to graph A gx equal x minus 2 square root, and let's say hx equal x plus 3 square root. Also find the domain and the range. Find the domain, find the domains and range. Okay, so let's answer. So the first one, so what happened? It is x minus 2. So according to theory, what you will do, you move the graph to the, you move the original graph to the right by 2 units. So we can say, so let's start with like this. Let's say we know, so we know y equal square root. This is one of the library functions, has the graph, so this is like that. So this is square root function, go like that. 0, you can start with 0, and then if you need a value, you can say, for example, at 4, which is 2, the square root. So that's the graph of square root function. So this is y equal square root x. So the domain of this function is 0 to infinity, and the range is also 0 to infinity, 0 including. Okay, now if you look at the first part, so what's the first part says? It's x minus 2 and it's inside. So that means it is a horizontal change because inside of the function it's a horizontal change. And it's changed horizontally to the right 2 units. So let's do that. So part A, the graph of uh, so part A means graph of y equal square root x shifted to the right, by 2 units. Okay, shifted to the right by 2 units. So that means so this is the original graph. So I'm gonna draw as a dotted line. That's the original graph. Now we're gonna shift this one to the right by 2 units. So that's the new graph. So this is 2. Okay, so you move the graph 2 units to the right. So what are the new values? So so let's say this is value 4. I'm gonna say this is 4, and then what happened? Now this is 6. This is gonna move to 6. 4 move to 6. Okay, so this is the old dot. This is the new dot. Good. So that's the kind of idea. It's a very simple. So you just move the graph to the, and there's a y-axis sitting there. That's the x-axis. So if you write the domain and range, so that's the domain of the new graph, which is g. So what happened? The domain now start at 2, so it is going from 2 to infinity. And you can see that there are no values less than 2. What's the range? And you can see this, since this is a inside change, there are no change the y vertical direction. That means still the same. So vertical value do not change. I mean range does not change because it's a inside function. So this is y equal x minus 2 square root. So just move to the right. Okay, let's do part B. So part B, the graph of y equal square root x. So you can see in the second one, what you will do is x plus 3. So x plus 3 means you're going to move to the left. So so it's shifted to the left by 3 units. Good. So as before, so we have this graph, the original graph. So that's the curve function. I'm going to draw it as a dotted line. This curve function. So what you can do, you're going to move that to the left by 3 units. So this is -3. So that is the new graph. Doesn't look good. Yeah. So this is the new graph. Go like that. So what is this value? To find this value, you can actually plug into the new function. So what's the new function? Y equal x plus 3 square root. So just plug in 0 to the function because at the 0, so that means this is square root 3. The value is square root 3. That is the new y-intercept. And also, I want to tell you something like, for example, there's another way to look at this one. So we have x plus 3 square root. To bring it to the same format, we can write this as like this: x minus 3. So that means when you have a positive value, it's going to move to the right, but since you have a negative value, this means that you move to the left because it's a negative value. So this is another way to look at it, because if you see x minus, like let's say x minus 3, now 3 is a positive value, so you move to the right. But since we have x minus 3, so we have moved to the left. So that's another way to look at the same situation. Okay, so let's look at the domain and range. So the domain is the one only change. So this case, like I think we call this is h. So domain of h is change. So it's going from -3 now, -3 to infinity. And you can see, since it is an inside change, there are no change to the vertical directions. That means the range is still the same, 0 to infinity. Good. So that is how you do horizontal shift. Let's do one more example, because this is like a sometimes like a little bit confusing. So we're gonna make sure that we understand this well. So let's look at another example. How about this one? Let's see. The graph of, so let's say graph fx equal x plus 3 absolute value minus 1. Yeah, absolute value of x plus 3 minus 1. And also find the domain of f and the range of f. Good. So let's look at the steps that we need for this kind of problem. So what are the steps? So we're going to start with y equal square root x function, that we know this is one of the library functions. And then the first step is we normally do inside first. So that means we're going to shift. So the first step is we're going to shift to the right. Actually, it's a +3. That means shift to the left. So we're going to get the graph of y equal x plus 3 first. And you can see this is simply you move the graph by 3 to the left to get this one. And then the next step is step 2. We're gonna move, it's a vertical change. -1 means subtract 1. That means move vertically down by 1. So that means to get this one -1, what are you gonna do? You're gonna move the graph down by 1. So those are the 2 steps. So let's do one by one and see how we can get it. So we're gonna start with the basic function. So we have the absolute function, that is the famous one. So go like that, go like that. So that is the absolute function. So this is 0, and this is y equal absolute value x. Now what we can do, we can shift this one to the left. So that is the x-axis and the y-axis. So we can move this one to the left by 3 units. So that means I'm going to make a slight change to the axis because we need more on this side. So I'm going to move the axis like that to get more on this side. So we have 0 here. So what happened now is that 0 moved to 3. Okay, so negative 3. So the new graph looks like this now. So it's going to go like there, like that. There's a new graph, and if you want, we can actually find the intercept there. So what is this new graph now? So this one is y equal x plus 3 absolute. Okay, it moved to the left by 3 units. And then the third step is we're gonna bring it down. Okay, so I'm gonna move the axis a little bit up there. Actually, we can have it there, then we can see what exactly happened. So that's the axis, x and the y-axis. So what happened now is, so it's gonna move down by 1. So this is the negative 3 value that we had earlier. And then now it's going to move down by 1. So that is the negative 1 because it moved down by 1. So that means the new vertex is over there. So that means your new graph looks like this. I'm going to go like that, like this. Okay, that's the new graph. And then also we can find, so this point is negative 3, negative 1. What is the new intercept? So you can see this graph is y equal x plus 3 minus 1. To find the new intercept, you can just plug in 0 here, or you can look at the transformation, like you can start with a point and then you can see where this new one is. But the easier way is to look at the equation of the last one and plug in 0. So if you plug in 0, you can see that is what do you get? You get absolute 3 minus 1, that means 2. That means this point is 2. Okay, new intercept is 2. Good. So that's what happened. So what is the uh, so actually if you want to write this as a point, you can just write this one as 0 2 because x coordinate is 0, y coordinate is 2. You can write like that, or just the intercept is 2. Good. So that is the new graph, and then you can see the domain and range. So the domain of this function is all real numbers. We write it like that. That's one way to write it. And what's the range? And you can see here we do both. Range is all R because you can see there's a value for any real number. What's the range? Range, you can see you move down. That means there's a vertical change now. You can see the smallest value is negative 1, and then you have any other larger value. So that means gonna start at negative 1, go all the way to infinity. So that is the range of this function. Good. So again, so what we did step by step. What we normally do is we can start with the inside and then go outside. So that is the easiest way. So we did the horizontal shift first, and then we did the vertical shift. We normally do the vertical shift at the last step. So this is something we remember. Okay, so that's about that. Let's do one more example, because this is like something that we really need to excel. So let's do one more example before we move on to the reflections. So because this is like sometimes people get confused about this one. So how about this one? I'm going to give this as an exercise. Let me you try this first and then look at the answer. So what we can do is sketch the graph of, okay, sketch the graph of fx, which is x minus 2 square root plus 3. Okay, no big difference. So you can see we can do the shift first. So that means it's x minus 2, that is standard form. That means you're going to move to the right 2, and then we're going to up by 3. So there are 2 steps like that. Good. Um, so let's start with the basic function. So what's the basic function here is the square root function that we know. So this is the square root function. Start with 0. So this is x and y. So the first step is we're gonna move that to the right by 2 units. So that we can do. So we're gonna move to the right by 2 units. That means 0 now goes to 2, and then you draw the function. So like that. So the square root function going like that. So this is the new one. So this is y equal x square root x minus 2 square root. You shift horizontally 2 units. So you can say shift horizontally 2 units. Good. And then the next step is you're going to lift it by 3 units. So so the new axis. So that's the x-axis. So what happened is you're going to lift, so the 2 stays the same because it is a outside change. 2 doesn't change. But what happened? 0 now goes to 3. So there was 0, but it goes to 3 now. That means that the starting point now move over there, and then the rest of the graph can start over there. Okay, so that's what happened. So that means the new vertex point here is, it is 2, 3. So that's what happened. Good. So, and that's a vertical change because it's outside, so that means vertically. First one is inside, so that's a horizontal. Okay, the first one is horizontal, second one is vertical. So that's the new graph, and you can see the domain and range. So the domain of this new one is, you can see it's going to start at 2, go all the way to infinity. The range is, so for the range, and you can see that that's the value start at 3 and then go up. So that means it is 3 to infinity. Again, so what we did in this problem, you can see first one is x minus 2. That means you move the original graph to the right by 2 units. And then in the second one, what we do, we add plus 3. So that means we move the graph 3 units up. So it's so you can do step by step. And for this problem, actually, you can even switch the order. So you can get the same graph. So I'm gonna write this as a note. So you can see we can start with y equal square root x, and then what we can do is we can move the graph 3 units up. So we do the outside one first, and then so what we can do is we can shift the graph 2 units to the right. So that means the equation that we're gonna get it y equal. So we can start with square root x, and then if we do the plus 3, so what happened? It is y equal square root x plus 3. Now what we can do? We're going to do the shifting. So when we do the shifting, it's going to be y x minus 2 square root plus 3. So you can get the graph following that order also, but we normally do the vertical shift at the end. So next, what we can do, we can talk about reflections. So we have the next one is the reflections. Reflections. So there are two types of reflections. One is the vertical reflection. Vertical reflection. So that means vertical reflection means it's so you can reflect vertically. So that means the situation is like a y equal negative fx. For example, you negate a function. When you negate a function, what will happen? You can change the sign of the y coordinate. Positive become negative, negative become positive. And then we have horizontal reflections. So horizontal reflections like means situation is horizontal. That means you have to change the inside of the function. So that means f a negative x, things like that. So those are the two reflections we're gonna talk about. So let's um, work on that in detail. So the graph of y equal negative fx. Okay, the graph of y equal negative x is the graph of y equal fx reflected about the x-axis. Reflected about the x-axis. So you can reflect about the x-axis. Okay. So reflected about the x-axis. So that means if you look at a situation, so what happened? So let's say we have a graph like that. So let's say this is your original graph. So y equal fx. So in the negative, what we're gonna negate the values. So that means, so what happened? It's just gonna reflect about the x-axis. So that means you're gonna get the mirror image. So once you get the mirror image, so you're gonna get like that. Yeah, so that is the new graph. So this is y equal negative f. You simply change the sign of the y values. You can see that there are no changes to x coordinates. It's only the y coordinates. Good, that's the first one. And the second one is the graph of y equal f negative x is the graph of y equal fx, because it's inside, so it's a horizontal change. That means you can reflect about the y-axis. The graph of y equal fx reflected about the y-axis, reflected about y-axis. So it's reflected about the y-axis. So that means if you look at a situation, so what happened? So let's say you have a graph like this. So this is the graph of a function, something like that. So what we can do, we can reflect about the y-axis. So you're gonna the y-axis. You can jump to the side. So that means you're gonna get a graph like that. Okay. So so this is the graph of y equal fx. So this is the graph of y equal f negative x. So that means inside is the changes in the horizontal directions. The y coordinates stays the same. So you can see, for example, if you look at these 2 points, they are the exact same y coordinate. There are no changes to the y coordinate. And the other one, if you look at 2 points, for example, this and that, they have the same x coordinate. Okay, with only change in y direction. Okay, so that's how you do the reflections. So let's do several examples. So how about we can start with this one. So let's say this example, a graph. So we did like quite a lot of examples just to make sure that we understand this one. So negative x cube and y equal x negative x square root. Yeah, this is like interesting one. Negative x square root, and also find the domain and range. Find the domain. So find their domains and range. Good. So let's start with the first one. Uh, so what is the first one? So we have the cube root function, and then we're gonna negate it's outside, so that means it is a vertical change. Uh, so we're gonna start with the graph, the cube root function, cube function on the cube function that we know this is like one of the basic functions. So the graph looks like this. So what happened is, so it's since it is a so we have y equal x cube. So what we need is negative. That means you're gonna reflect this about the x-axis. Okay, so reflect about the x-axis. So that means uh, so we're gonna get this one. Uh, so so this side gonna go that way, and the other side gonna go down. So that means so you're gonna get a graph like this. Yeah, so that is the graph for the new one. So this is y equal negative x cube. So you reflect about the x-axis. Good, no change in the uh, x coordinate. It's only y coordinates. Okay, part B. So in the part B, so we have y inside. So y inside means a horizontal change. That means you reflect about the y-axis. So let's start with the graph. So we have that. So there is square root function. So like that. Start with 0, going like that. But what we can do now is, so this is the graph of y equal square root x. So since we it is inside the function, so what we can do, we can shift, we're gonna reflect it about the y-axis. Okay, so that means it's gonna jump to the other side. So that's the new function. So if you draw it, get so we're gonna get a graph like that. So start with 0. So that is the graph of y equal negative x square root. Okay, so it's very clear. We reflected about the y-axis in this case. Okay, that's what the theory says. Okay, it's very simple. Okay, let's try the domain and range. So what are the domain? What's the domain of the first one? So you can see the domain of the first one is all real numbers, and the range is also all real numbers. What about the second one? And you can see so what happened here is inside, so y doesn't change, that means range doesn't change, but it's going to change the domain. So what happened to the domain? You can see earlier it was from 0 to infinity, so domain is 0 to infinity, but it's simply going to reflect, so that means it's going to be negative infinity to 0 now because you reflected it. Okay? So everything reflected across the y-axis. So jump to the other side. Good, that's the domain, and you can see the range cannot change because inside, and you can see it is still the same 0 to infinity in both cases. Okay, so here also the range is 0 to infinity, no change. Okay, that's about that. Let's do more examples just to make it clear, but you can skip if you want, and you can see the timestamp in the description. So if you are comfortable with this one, you can move on to the next topic, the stretch and shrink. So let's do one more example of this. So how about this one? Uh, so let's say sketch y equal 2 minus x plus 1 square, and then also find the domain uh, and the range. Okay, curly D and curly R, that's the notations. Okay, so if you look at steps, what are the steps here? We normally do the shifting first, so that means the first step is this one, and then we do the reflections, and then at the end we do the vertical shift. Those are the kind of order that we use, and so we're gonna follow those three steps and get the final graph. So let's start with one by one. So we have the basic graph. This is y equal x squared graph. So we're gonna start with that. So the y equal x squared is like that. Now what we're gonna do, so this is 0. We're gonna also mark what will happen to the 0. So the next one is we're gonna move to the right. Actually it's a x plus 1. Since x plus 1, you move to the left by 1 unit. Okay, so that's the next step. So in the next step, what we do, we're gonna move to the left by 1 unit. So let's do that and see the graph. So I'm gonna kind of slowly move my axis because most of the graph is on this side. It's always a good practice to do it like that, um, because we kind of try to show the graph. Okay, so what happened? You can see that point 0 now move to -1 because you move to the negative side, and then the new graph looks like this. Go like it's gonna go like this. Parabola, you have to roll like a parabola. Okay, good. So that's the shape of the graph. So we can also and then we normally put arrows to mean that it's gonna continue like that. So what is the value in case like if you need the intercept? You can see what is this graph? What is the equation of this one? So y equal x plus 1 squared. So that means if you plug in 0 here, you're gonna get the intercept. That means 1. So the 1 is intercept. Good. Uh, so this point is -1 0. Good. So that's about that. And the next one, we're gonna do the reflection. So let's do the reflection now. So it is a minus outside. So that means what we're gonna do, you're gonna reflect about the x-axis. Okay. So that means we're gonna get the graph like that. So I'm again gonna move the axis over there just to get more detailed. So what happened? No change in the x direction. It's only y direction. So that means the 1 jump to -1. So that means the new graph looks like that. So gonna go like that. Touch. So we put arrows, and then you can see 1 now jumps to -1. This value does not change. So -1 0 because it's only a vertical change, no horizontal changes. Okay, and the last step. So what's gonna happen in the last step? And you can see you're gonna add 2. So add 2 means it's gonna move up by 2 units. So that means so new graph looks like this. And see, we need more up there. That means I'm going to change the axis little down there. And so you can see every time I change the axis just to get a more detailed. Good. So what happened now is you can see that the point the intercept moves to 2 now. So it is 2. So it would be better to change the axis like a little bit because you can see the intercept, y-intercept is 1 now because you move -1 by up 1. So that means it's going to change. So I'm going to slightly change the axis just to get more detail. So let's have it like that. You can see this is very useful. So what happened now is um, the intercept is 1 at 1 now, and then the point moves is at so it's not at 0 but it's going to go to 2. So 2 actually it's a -1, so it's a -1 and 2. So that's where the new intercept new vertex is. So that means if you graph the function you're gonna get something like that. So it's gonna go there, and it's going to pass through this value. So that is the new graph. Good. Okay, that's what you get. So that's the intercept. Um, good. So what's the domain of this function, the range of this function? Actually, also, so this point is actually 2 now because it's lifted up by 2. So change the y coordinate of the vertex by 2 from 0 to 2. And so this equation is, now the equation is y equal to minus x plus 2 x plus 1 squared. Okay, yeah, so this one is y equal minus x plus 1 squared only, but now here we lifted by 2. So let's try the domain and range. So the domain is negative infinity to infinity. What's the range? And you can see range changes now because it's going to go all the way down. So it is from negative infinity all the way up to 2 including. Okay, so that's the new range. Good. um, so that's about that. So let's do the next one. So what is the next one is about the vertical, that's the last one, vertical stretch and shrinking. Okay, so let's talk about that. So vertical stretching and shrinking. What we can do in this situation is we have y equal a fx. So we multiply outside, so vertical change, so multiply outside. So there are two cases to consider. What if a is greater than 1? What if a is, so we assume a is positive. If negative is just a reflection, we can consider this as an extra step. So if it's a positive, what happens? You can stretch, and if a is, no, I'm sorry, if a is greater than 1, you're going to stretch. If a is between 0 and 1, so you're going to, it's a fraction, so you can shrink. So that's what happened in those two cases. So let's write the detailed. So we have uh, to get the graph of, to get so we can say yeah, to get the graph of, to get the graph of y equal a fx. First one, if a is greater than 1, stretch the graph of, you can scale, stretch the graph of y equal fx vertically. Y vertically is outside, so vertically stretch the graph of y vertically by a factor of a, by a factor of a, by a factor of a. And then the same thing if a is in between 1 and 0, shrink the graph of, shrink the graph of y equal fx again vertically, shrink vertically by a factor of a. Okay, shrink vertically by a factor of a. Good. So that's the situation. So that means if you kind of draw it, so this is what's going to happen. Um, so let's say you have a graph like this. Um, so this is the uh, original graph. Now if you stretch, you get a graph like that. So it's going to stretch. Um, so this is the situation a greater than 1. So this is this one is the y equal fx, and this is y equal afx. So it's very clear. You just multiply the y coordinate. It's a stretch, just the y coordinate. And the other one you can see like this. So let's say this is your original graph. Now you're going to shrink it. So that means your new graph is smaller, like that. So the top one is y equal fx. The bottom one is y equal afx. And here what happened, a is between 0 and 1. That's why it's gonna make it smaller. Okay, scale down, scale up, and scale down. Okay, so let's look at a situation. So this is a problem. So let's say graph a gx equal 3x squared b hx equal 1/3 x squared. So what happened here? So that's a scaling, one stretching. So the first one we can see is x squared, that we know. So that's the graph of x squared. That's the parabola. So now what happened is let's do like this. So the first one, we'll do a and b. So it's a and b. So for a, what we can do, we can stretch by 3 units. So that means, so what happened, so let's say you have the point 1 and 1. So what happened to that point 1, 1? So it's going to be 1. Now it's going to go to 3 because you're going to do is 3 times. So it's going to go there, right? So that means if you look at the new graph, it's going to look like this with stretch. That's what happened. So if you look at the original graph, it passes through 1. So that's the original graph. So this is the original graph. That's the original graph. This is the new graph. Okay, stretch by 3 units. So 1 become 3. So stretch. So that's the new graph. Okay, and then the other one, part B. So in part B, what is going to shrink. So if you look at the original graph and the new graph, so what happened? So we had a point 1, 1, but 1, 1 now goes to 1/3. So that means the new point is over there. That means if you graph the new one, so so it's gonna go like that, and on this side also gonna go like this. Good. So that's a new graph, and if you also draw the old graph, that go through that point. So that means that's the old graph. That's the old one. That's a new one. Okay. So the new one is y equal 1/3 x squared. The old one was y equal x squared, and you can see what happened. It's gonna scale down. Good. So and then also you can see this point is 1/3 now. So this point is uh, 1/3. Here this point is 1/3. Okay? So that's what happened to that point. So that's about vertical shift. So let's do like a one which combine maybe two steps. Let's do an example like this. So the next example, um, we can do sketch. So sketch the graph of let's do a little complicated one which has like multiple steps. So how about 1 minus 2 x minus 3 squared. So again, there are certain steps that we normally start first. So we know that we do the horizontal shift first, and then we can do the scaling here. And then we do the reflection, and then the shift, vertical shift. So we can do it like that. There are certain steps that you can switch, but not always. So let's go one by one. So we can start with the y equal x squared, the parabola. That's like a common graph that we know. So we can start with that. So we have this. So this is y equal x squared. So the next step is we're going to shift to the right. Shift to the right by 3 units. So we can do that. That means we're going to get this graph. I'm always think about how to best draw the axis to get more details. So 0, now 0 move to 3, so it is at 3. So the new graph looks like that. Okay, good. So if you want to write the equation is y x minus 3 squared. And if you also want to find the intercept, and you can easily find the intercept now. So this point is 3, 0 over there. And you can see if when you plug in 0, you get 9. So this 9, the intercept is 9. Okay, so the next step is, so we start with step 1. And step 2. Step 2 is scaling. The reflection, actually this, yeah, scaling and reflection. There are 2 steps, but you can combine them into one, because you can do it as 2 steps. First you scale it, and then you reflect it, or you can combine the 2 and 3 steps and write just one, so that may be much easier. So we can do that. So I'm going to move the axis. You can see most of the graph is down there, so that means I'm going to move the axis like that. Good. So that means 9 now goes to negative, because it's going to multiply by -2. That means -18 now with that value, because it's a vertical change, just a vertical change. And you can see this value is whatever the y value multiplied by -2, that's why you get -18. There are no changes to the x direction, so 3, 0 stays at 3, 0 because it's outside change. So now the new graph looks like this. Can see stretch, the graph stretch now. Good. And then what we can do, so that's the next step. Okay, so this is reflection and stretch, so it's a multiply by 2 and also reflection about the x-axis. Okay, so the next step is we're gonna move. That's, we normally do that the last step. So say and up. So this is like end. Good. So the next one is we're gonna do the vertical shift by 1. So if you do vertical shift by 1, so we need more space. So I'm gonna again slightly move the axis just to get more details. So like that. So what happened? You add 1 to all the points. So that means your vertex move to over there. So this is 3, 1 now. That's the new vertex. And the negative 18 go to negative 17. We add 1. So the new graph now looks like this. Uh, yeah, it just shifted vertically by 2 units. Okay. By 1 unit, not 3. Yeah. So that's the graph of the final function. Okay. So and then we can also write the domain and range, and you can see domain is still the same, all real numbers, but the range changes. You can see it's negative infinity go all the way up to 1. Okay, let's go up to 1. So it is negative infinity all the way up to 1. So that's the so that's how you like a problem with multiple steps, and there are certain steps that you can combine, and there are certain steps that you can reverse. Like you can even change the order, but we normally do the vertical shifting at the last one. But when you have scaling reflections, actually reflections and horizontal shift, certain times you can even reverse the order. So only thing that you have to worry about when you do the vertical shift and the scaling. Um, Good. So that's about that. Uh, so let's talk about and then I'm going to give you one problem as an exercise. So why don't you try this one? So so let's say this problem. So this is an exercise. So sketch gx equal 3 minus 1 half x plus 4. Okay, so try to graph it and also find the range of the domain. So find the domain and the range. Good. So let's do the last one. What's the last one? Is the horizontal stretching and shrinking. Horizontal. So this is a little bit of confusing one, and that's why I'm going to do it at the end, because everything else is like easy. So let's see what's going to happen here. So if you have a, so the problem that what we're trying to do is like ax. Like you can see, it's inside, it's horizontal, so it's inside. Again, we can talk about two cases. A is greater than 1, and A is in between 1 and 0. So, so what happened? You can see, since you are multiplying like a by a, like let's say the case like where you multiply by a value which is greater than 1. So if you multiply by a value which is greater than 1, what's going to happen? Since you multiply to get a multiply a value by greater than 1 to get the same value, what you can do, you have to shrink the x value. So that means if you multiply by a larger value to keep the value the same, what we're gonna do, we're gonna shrink the graph, so it's gonna go backward now. Okay, so if you have, so that's why the horizontal shift is kind of little different. So I'm gonna put a mark here, because you have to be careful with this one. It's gonna go backward. Okay, if you multiply by larger value, it's gonna shrink. If you multiply by a smaller value, it can stretch. So this case is gonna happen, it's gonna shrink, and this case gonna stretch. So it's gonna go backward. So let's write it in word. So we can say so the graph of y equal f ax is inside, that means horizontal changes, is the graph of y equal fx, is the graph of y equal fx. Let's do the two cases. The first one, shrink horizontally by a factor of 1 over a. It's not a, it's a 1 over a. And why we're going to do that? And you know that when you multiply to cancel out that, we're gonna multiply by the reciprocal of that, so so that they cancel each other. So it's a shrink vertically by a factor of 1 over a if, okay, if a greater than 1, and then stretch horizontally again by a factor of 1 over a if a is in between 0 and 1. And you can see that there are more explanations for this one. And what's going to happen if a is greater than 1, 1 over a is smaller. You can see that. That's why we say shrink. It's going to shrink, because if a greater than 1, 1 over is smaller, it's going to shrink. If a is in between 0 and 1, which is a fraction, 1 over is bigger than 1. That's why it's going to stretch. So you can see it's going to go backward because it's 1 over a. But everything else you have the a, but here it's like 1 over, so it's gonna reverse the order. That's like another way to remember that. That means in this one it's gonna shrink, so we normally like draw two arrows like that to mean shrink. In the other case, it's gonna stretch, so we're gonna draw arrows like that. So that's the kind of notation we're gonna use in this situation. And you can see that it is different from vertical stretch and shrinking, because this exactly opposite happen here. Okay, so let's try this as a note that can help you later. So different from vertical, because that's one is easy, because if multiply by large value, it's going to get large. Multiply by smaller, it's going to smaller, but here it's going to go backward. So different from vertical stretch and shrink. Okay, stretch and shrink, because this is gonna go backward, like it's opposite. Okay, so let's look at some examples here. uh, so how about this one? uh, so we have the graph of y equal fx is given. Sketch the graph of y equal 2fx, so which is outside, that's mean a vertical stretch, and y equal f3x, so which is inside. That means which is a shrink. Even though it's 3 large, it's going to shrink because it's more than 1. It's going to shrink 3 times. And find their dominant range. Okay, so let's do one by one. So let's say let's say this is the um, graph of fx. So we have this graph. um, so we're gonna learn this later. This is one of the trigonometric function. um, and we also have these values. So this is pi over 2 1. So this is 3 pi over 2 negative 1, and also we have 5 pi over 2 1. So we have those values. So let's see what's the graph of the first one, and you can see that that's going to stretch by 2. You're gonna vertically stretch by 2 units. Okay, so let's look at that now. So part A is stretch vertically, by a factor of 2, okay, stretch vertically by a factor of 2. That means so let's draw both graph in the same scale. So we have this one. So the original graph is this. So this is between 1 and negative 1. So we have pi, 2 pi, and 3 pi. Now what happened? This is going to stretch, so that means it's going to jump that 1 to 2, because you can multiply by 2. So it's going to go negative 2, and it's going to go 2. So that means the new graph is like that. Good, and you can see that that's the new value is because you stretch by 2, so the new value is 2 now. Okay, old value is 1. So here old value is -1, new value is -2. Okay, so that's what happened in this case. So if you, for example, if you need this point, it is pi over 2, no change in the horizontal direction. Vertically is 2 now. And also, for example, if you need this value, no change in the horizontal direction, x coordinate is the same, but the new y coordinate is -2. So that's what happened in the first case. So let's do the second one. So second one is shrink, because when you if it's horizontal, if it's a larger value, it's gonna shrink. If it's a smaller value, it's gonna stretch, it's gonna backward. So shrink horizontally by a factor of so it is, since you multiply by 3, it's a factor of 1/3. That's going to shrink. So it's gonna factor of 3. It's gonna shrink. So if you look at the graphs again, um, so we can graph for comparison. We can graph the original one and the new one. So this is the original one, and which has value 0, pi, 2 pi, and 3 pi. So what happened? It's gonna shrink now 1/3. So that means so we have 1. That 1 goes to 1/3. So that's the new value. So that means it's gonna go there. Oh, actually, so what happened here is it's a shrink, but it's a shrink in the what direction? So it's not 1/3 on this side. So what happened is you're gonna shrink by 1/3. That means it's gonna be horizontal changes. Okay, not vertical. It's a horizontal changes. So so we don't need this one. So what happened is it's a horizontal. So that means 3 pi. If you shrink it by 1/3, it's going to be pi. That means the point at 3 pi moved to pi now. So that's what happened. And the point at pi now moved to pi over 3. So like that. And then point at 2 pi going to go. So the point at 2 pi going to go to 2 pi over 3. Point at pi going to 1/3, I mean pi over 3. So that means the whole 3 cycles now going, all those peaks going in the first from 0 to pi, everything because shrink by 1/3. So that means so new graph gonna looks like this, and like that. And you can see all the graphs like shrink 3 times. So shrink 3 times means 3 pi become pi, 2 pi become 2 pi over 3, pi become pi over 3. Okay, so those are the new values. For example, this value is now pi over 3. Good. And there are no changes in the vertical directions. The vertical value stays the same. So that means this is still -1. Okay, so that's what happened in the vertical and the horizontal stretching. Good. So the vertical one is easy. A horizontal one we have to be careful. And then so what is this new graph? So this is simply y equal f 3x. This one is y equal to fx. So what happened? In the vertically it's easy, but if you do horizontal, if it's inside, if you multiply by a larger value, it's gonna shrink the graph. If you multiply by smaller value, it's gonna enlarge. Okay, so that's about that. So that's like all the material that we need to study. What I will do, I will do a few more examples just to make sure that we understand the topic. Okay, also, so what happened here is gonna shrink 3 times. That's how we call it, shrink 3 times. And what happened there? Enlarge 2 times. Okay, good. So let's do a few more examples just to make sure that we understand this. Otherwise, the theory is over. So what the question is, find the equation of the graph obtained when the following series of transformations, apply it to the graph of y equal fx. So what are the steps? So the first one is we can do shift left 2 units, shift left 2 units. That's the first one in this order. Okay, that's important. And then shift up 3 units, shift upward 3 units, and then let's say reflect about the y-axis. Reflect about the y-axis. Okay, so those are 3 steps, and we can apply those in this order. So what's going to happen? So the answer. So the first one, we're going to start with y equal square root x. No, it was absolutely x. So that was the first one. So we can apply the first transformation. Shift left 2 units. So when you do shift left, that means you're going to add plus 2 to the x coordinate. So that means you're going to get y equal absolute value of x plus 2, because that means shift left. Okay. So when you do shift left, you're going to add plus 2 to the equation. That's the first step. The second step. So in the second step, what we can do, shift up by uh, 3 units. So this is shift up by 3 units. That's the second one. So that means so it is x plus 2. So up means you can add 3. Okay, that's a shift up by 3 units. And the next step, what we can do is say reflect about the y-axis. When you reflect about the y-axis, that means you're going to change, because reflect about the y-axis means you're going to change it horizontally. That means you're going to change the function inside. That means you replace x by negative x. So that means we have y equal negative x plus 2 plus 3. You can also write this one as 2 minus x if you want, plus 3. So that is the so that's a reflection. So the last one, because you reflect it about the y-axis, that means you simply change x to negative x. Okay, so that's what happened here. Okay, so that is the new equation. Okay, after you do those 3 steps, and you end up with this equation. Good. That's the first practice problem. So let's do another one. How about the next one like this? So what the next expression says, the point -1, 4 is on the graph of y equal fx. So find the corresponding point. What's the corresponding point? Means the image. Where is that image of that point? Okay? The corresponding point. Find the corresponding point or the image of -1, 4 on the graph of this function. If you have this function, if you add this transformation, where the new point is. So so we're gonna again go with those steps. So what we're gonna do, we can do the horizontal shift first, and then the scaling, and then the vertical shift. So let's do one by one and see where the new point is. So let's start with, so the answer, we're gonna start with y equal fx. So the point is -1, 4. So that's the point. Now we can apply the first transformation. So when you do the first transformation, your new equation is y equal f x minus 2. That's the first one. So that means what happened, you can see it's gonna shift the point, shift the x coordinate by 2 units. So if you shift the x coordinate by 2 units, that means -1. So it's only affect the x coordinate. So the -1. So that -1 is going to be, if you add 1, it's going to be 1, 2, 4. Okay, so that's what happened. So -1 become 1 now because you shifted by 2 units. Shift by 2 units, the x coordinate. Okay, so the next one, we're gonna apply the second one. What's the second one? We can do half. So it's y equal half of f x minus 2. So that means is outside change. So that's it's just gonna affect the y coordinate. So that means it's gonna half of the y coordinate. That means it's gonna be 1, 2, because you get the half of 4. Okay, it's only affect the y coordinate. So we'll get the half of 2. Now the next one, we can do step 3. The step 3 is shift by. So here what happen is you're gonna shrink like that. So you're gonna half of them. Okay. So now the next one is y equal is the shift. So 1/2 uh, uh, 1/2 f x minus 2 uh, plus 3. That means it's a vertical change because outside up 3. That means only affect the y coordinate. So it is 1. You're going to lift by 3. That means 2 become 5. Good. So that's what happened. So you can see it's only affect the y coordinates. That is the image of that. That means negative 1, 4 now transforms to 1, 5 under this transformation. Okay. So that means you can say negative 1, 4 transform to 1, 5 under this transformation. Under this transformation. Good. Okay, that's about that. So it's not that difficult, but that's how we do it. So go step by step, and every time you see what is the new coordinate. So let's do a graphical one. So let's do a little difficult one and see like how it's gonna work. And then after we can do 2 more algebraic questions. Okay, so let's do next one. It may be a little difficult, but let's see how it works. Uh, so the graph of f is given. Find the graph of gx equal 3 f 4 minus 2x minus 1. It's a very interesting question. I'm going to start here. So it can be tricky sometimes. So let's say, so this is the graph of f. So we have this one. So now the question is, if you apply those transformations, what is the new graph that you obtain? So so we can do actually a problem like that in 2 different ways. One is we can find the images as we did before in the previous example. We can find the images of those 3 endpoints. So we have 3 endpoints here. So for example, we have 4, 0. That's one endpoint, and we have negative 2, 0. That's another endpoint, and then we have 0, 2 over there. So those are the 3 endpoints. So what we can do, as before, we can find the images of those 3 endpoints, and we can connect the dots. Okay, so that's one way to do it. Find the images. So method 1. So find the images of 3 endpoints and connect the dots. That we can do. That's like method 1. But we do method 2, that as we did before, we can go to the actual transformation step by step. So that's the like most interesting way. So how we can do that? Before we do that, remember we need to bring it to the equation to the standard form. So what's the standard form here is, and we can rewrite this one as 3f. What we can do, we can write this one as x minus something. So if you say x minus something means you can pull negative 2 out. When you do that, you can write this one as x minus 2, because when you divide each term by negative 2, that's what you get, negative 1. So this is the standard form, and you can see in the standard form you have x minus 2 term. So we're gonna rewrite to this form first. Now we're gonna go step by step. until we get the graph. So, and you have to be careful here. If you get a problem like that, so there are certain steps that we do first. So for this problem, so what we can do, we can do the scaling first, and then we do the shifting, because x you can change it to x, so that's means you're going to shift the graph, and then we do the scaling, and then we do the vertical shift. Those are the orders, and you have to be careful. If you try to switch step 1 and 2, you really do not get the graph correct graph in this time, because you have to be careful, because if you try to do shift first, and when you try to scale, you are actually scaling like a something else. So that the order matters. So when you have a scaling and a horizontal shift, do the scaling first and then do the horizontal shift. So this is like interesting problem. If you want to like dig more into it, see what will happen if you switch the order, and you can see the images are not the same. So let's do the first one. So what's the first one? We can do y equal f negative 2x. So what is f negative 2x means? It's gonna reflect horizontally and also scale halfway. Okay, so we can do both of them. So if we do that, so what kind of graph we gonna get? So let's do both. So what's gonna happen is gonna reflect to the other side, uh, and also gonna scale down by 2. That means so negative 2 on the other side, I'm gonna jump to a 1 on this side, and so also the 4 4 on the other side jump to negative 2 on this side. So that's what happened, and there are no change to the vertical direction. That's 2 stays the same. Good. So the new graph, so that's the graph of f negative 2x. Why is the case? It's gonna flip because of negative sign, and then go halfway in the horizontal direction because of the 2 factor 2. Good. So the next one. So what's the next one? So we're gonna move on to the next step. Horizontal shift. So we have y, which is f negative 2 x minus 2. So what that does is gonna move the graph 2 units to the right. So let's do that. Um, so once you do that, you're gonna get this graph. So it's gonna move to the 2 in it. So that means negative 2 go to 1. So yeah, 1, 2, 3, and then 1 goes to 3, and then the vertex stay as the same y value, but still is moved. So the new graph is now, it's just gonna go like that, and gonna go like this. Okay, but the value is stay at the same 2. So that's what happens. So this is the f negative 2 x minus 2. Okay, so the next step is we're gonna scale it by 3 times. So let's scale it by 3 times. Actually, it would be better to like change this, because I don't have space there. I'm gonna change the problem a little bit. So let's say we're gonna change this 3 to 2, just to make it reasonable. So we have 2. Good. In the exam you can do that, but here I don't have space there, so I want to like make it looks like correct. So that's why I did that. Good. So now what happened? It's gonna just scale vertically by 2. So that means these points does not move; they're gonna stay there. So this is 2, 4, and 0. That 2 gonna jump to 4 now. So 2 jump to 4. That's the only change happened here. So that goes there. So that means the new graph is this one. Uh, this is a line. It doesn't look like a line. Good. Okay, so that's what happened. And that's the all graph. So all graph was here. Good. So scale by 2 times. And then the last step. So what is this graph? So this is y equal 2 times f negative 2x minus 2. Yep. And then the last thing is you're going to subtract by 1. So that means you're going to move the whole graph down by 1. So we might need to slightly move the graph a little bit just to accommodate this space. So we're going to do that. So that's the axis over there. So we have 1, 2, 3, 4, so 0. So we have 2, 4. Those are the values we mark. And then we have 2 and 4 as before, but it's down by 1. So that we everything down by 1. So that means the new points are that point at 0 now is moved over there, and then point at 3 move over there, and then the point at 2 it was over there, but now it's go there. Okay, that's what happens. So that means the finally you're gonna get the graph like this. Okay, so this is that and go like this. Good. So that is the negative 1. This is 3. So this point is this point actually. This point is 2, 3. Okay. So that's the new point. That's new graph. So this is the second method. We're gonna go with the transformations. The other method is you can find the images of those 3 corner points and then connect the dots, and it's gonna give you that one. So that's like sometimes works. Okay, so if you have a lot of points, that's what we do. Actually, now because these kind of ideas we use in cartoons, like when they create, like when you get a new image, that's what you, or some other transformations that you like image processing. They use these kind of ideas. What they normally do is they just write a program and then calculate the images, because that's much faster. So they can do it like that. So you get the new points and connect the dots, and then you get the new graph. Okay, because these are very useful in computer science and some other engineering applications. Okay, that's about that. And also it's a really nice project to see what happened if we switch the order 1 and 2. If you just first shift and then try to translate and see whether you get the same value. So if you do that, please write that in the comment section, because it's really going to be like a nice interesting problem for you, like as a nice research problem. So what happens if you try to switch the first 2 steps, 1 and 2? Others are we know that like normally we do for step 4 at the end, but what happens if we switch the 2? Do we get the same one or we get something else? Okay, that's a nice problem for you to try. Okay, so we can do 2 more graphing problems. So let's try to do these 2 graphing problems. So the next one is this. Um, so let's say, so the example, I just simply say the graph the function, graph the function fx equal 1 minus x square root. So this is very similar to the last problem, and remember I told you that when you have a scaling and a horizontal shift, we normally do the scaling means the inside. A horizontal scaling, what we normally do, we do that first and then do the shifting. Plus 2. Okay, so that's the question. And also find the domain and range. Find the domain and the range. Find the domain and range. Okay, so how to answer a question like that? So you can see so the answer. So we're gonna write this in standard form. So we have 1 minus x square root. This is not in standard form. In the standard form, it should be x plus or x minus something. So what we're gonna do, we're gonna pull the negative sign inside. Once you put the negative sign inside, you can write this one as x minus 1. So you can see when you simplify, you get the exact same thing. So we do that because now it is in standard form, and you can see the horizontal shift to the right, and also we see the negative horizontal shift, horizontal reflection because of the negative sign. So you're gonna shift it, reflect horizontally. So what this means, it's gonna jump to the other side. Okay, so it can jump to the other side across the about the y-axis. So that's clear, and then we're gonna go step by step. And again, what is the first thing we do? Okay, actually I forgot the plus 3. So let's add plus 3. So we have plus 2 actually, plus 2. So we have plus 2. So what are the steps here? So the first one, we can do the horizontal shift. No, we're gonna do the reflection first, and then we do the horizontal shift, and then we do the vertical one. That's the order. So please remember that when you have a horizontal shift, horizontal scaling, we do that first before we do the horizontal shift. Okay, scaling we do first. Okay, so let's go one by one. So what are the graphs now? So we have y equal square root x, that's the starting point, and we know the graph of that. So that's the graph of that. Start with 0. And then we move on to the next one. What's the next one? We do y equal negative x. That's the next one. We do the reflection. So once the reflection, what's going to happen? You can see it's going to jump across the y-axis, right? Jump across the y-axis, reflected about the y-axis. So that means your new graph going to look like this. Since it jumped to this side, I change the axis to this way. So what happened? It's gonna jump to the other side. So it's gonna go like that. And then so the next one. So what's the next one? We can see y. Now we're gonna do the horizontal shift. So which is square root negative x minus 1. That means you're gonna shift this by 1 to the right. So we can do that. So that means our new graph gonna look like this. Yeah, let's change this axis over there. We don't need too much space on this side. So like that. So what happened? 0 now jumps to 1. Okay, so the graph gonna go like that. Good. Now what we can do, the last step, we can add 2. Okay, so we have the last step, which is y equal negative x minus 1 square root plus 2. Okay, so what does that? It's gonna move the graph 2 units up. So so we have the graph moving up 2 units. So it's at 1 0 earlier, but now it's going to 1 to 2. So it is 1 to 2. So the graph is going like this. That's the graph. So this point is 1 to 2 0. Okay, so that's the graph of the function. So and then also we can find the domain and the range. So I think it's very clear now. So algebraically these two are the same, so you can simplify this again. So once you simplify, you're going to get 1 minus x square root plus 2. Okay, so what we did, we bring it to the standard form before we talk about the transformation. And one more thing we remember is we do the reflection, horizontal reflection first before we do the horizontal shift. We do the horizontal reflection first before we do the horizontal shift. Very good. So what's the domain and range? And you can see the domain of F. Domain of F is domain of F is uh, all the numbers going up to 1. So you can see negative infinity up to 1. And then the range of this function is, you can see, it's going to go start at 2 and go up. So that means 2 to infinity. That's the domain range. Okay, so let's do 2 more examples. And actually, let's do just 1 more example. So this is the last example. So as the last problem, let's look at this one. So it's a graph, fx equal 3 over x plus 2 minus 1. So if you get a problem like that, how we can do it? So you can see it's very clear here. We're gonna do the horizontal shift first, and then do the scaling, and then do the vertical shift. So let's start with one by one. So we have y equal 1 over x. That is one of the graphs that you want to remember. So that means we can start with this one. So this is the graph of 1 of x. This is what we normally call the um, rectangular hyperbola. So this is like, for example, you have 1. If you put 1, you get 1. So if you look at the domain of this function, you can see domain is everything except 0. Range is everything except 0. So that's the graph. Now we're going to move on to the next one. So what we're going to do, we're going to do the horizontal shift. So it's a y equal 1 over x plus 2. So if you do that, what's going to happen here is, you can see it's a plus. Then we're going to move to the left 2 units. So the new graph looks like this. That means you're gonna 0 gonna move to negative 2, and then so these are what we normally call the asymptotes. Uh, uh, so that's also moves, and then you can see the new graphs gonna go like that and like this. Okay, so that's that. And then also if you plug in x equals 0, you see this is 1/2. Okay, so the next step is scaling. So we do the scaling now. So that means we're gonna graph the function y equal 3 times x plus 2. So that means you scale 3 times. So it's going to stretch vertically 3 units. That means no change to the y direction, no change to the x coordinates. So it's stay at negative 2. So only thing is 1/2 now go to 3/2. So I'm gonna, yeah. So we have 3/2 now. So it's 3/2. So the new graph is going like this. Good and good. Okay, so the last one is we're gonna move this graph down by negative 1. So since it's down by negative 1, now it's gonna move the asymptotes down by negative 1, 2. So this is negative 1 and this is negative 2. And then also we can evaluate the y-intercept. So if you plug into the function, you can see y-intercept is 1/2. So that means the graph passes through 1/2. So you finally get the graph like this. So we have this, and also on the other side we have this. Those are the asymptotes. Okay, so this is the end of the transformation video.